we're asked to find the antiderivative of each function. To find the antiderivative, we need to determine the indefinite integral of the given functions. So for the first function, we would have the integral of 7 divided by the quantity x squared plus 1. And now looking at the integration formulas on the right, the integral resembles this integration formula here, except in the formula, the numerator is 1, and we have a numerator of 7. But we can go ahead and factor out the 7 and write this as 7 times the integral of 1 divided by the quantity x squared plus 1. And therefore the antiderivative is 7 times inverse tangent of x plus c. For the second function, we would have the integral of 5 divided by the product of 2x and the square root of the quantity x squared minus 1. Again, looking at our integration formulas, notice how this integral resembles the integration formula shown here at the bottom, except in our integral, we have a numerator of 5 and an extra factor of 2 in the denominator. But we can go ahead and factor this out as 5 halves. This is equal to 5 halves times the integral of 1 divided by the product of x and the square root of the quantity x squared minus 1. Which means the antiderivative is 5 halves times inverse secant of the absolute value of x plus c. And then finally, for our last example, we have the integral of 2 divided by the square root of the quantity 16 minus 16x squared. Again, looking at the integration formulas, based upon the form of the integrand function, this somewhat resembles the integration formula shown here, except under the square root, the formula has 1 minus x squared, and we have 16 minus 16x squared. So we are going to have to change the form of the function in order to apply the integration formula. And let's show some of that work above. Let's factor out 16 from 16 minus 16x squared. This will give us 2 divided by the square root of 16 times the quantity 1 minus x squared. And the square root of 16 is equal to 4, and therefore this simplifies to 2 divided by the product of 4 and the square root of 1 minus x squared. 2/4 simplifies to 1/2. The function simplifies to 1 divided by the product of 2 and the square root of 1 minus x squared. Which means we can write the integral as, let's factor out the 1/2, 1/2 times the integral of 1 divided by the square root of the quantity 1 minus x squared. And that matches the formula perfectly, and therefore the antiderivative is 1/2 inverse sine x plus c. I hope you found this helpful.